Okay, in this video we're going to be talking about division. So there's a couple of ways you can write a division problem. So these are the basic three ways. You can write it in a sentence, which is the first way. Just turn my pen on. So this is a sentence, a number sentence. This is the symbol that says division. You can write it as a sideways fraction, a vertical fraction, or you can write it with this symbol right here, which will be getting you ready to do long division. All three of these are read A divided by B. So in a division problem, A divided by B, the result is called the quotient. So the result is the answer. Okay, the answer is the quotient. The number A is called the dividend. So A divided by B equals some quotient. Here is A, that's the dividend. And then B is called the divisor. So that's just some vocab going along with it. Okay, so then I want to talk about how you could interpret division. So let's do that on the next page. Well, let me go back. We may need to do a little bit of it here. So I've cut off a little bit, but 8 divided by 2 can mean 8 groups divided into groups of 2. So this is 8 groups divided into groups of 2. And in your handout, you can see that it says 8 divided by 2, we'll do it over here, 8 divided by 2, same number sentence, can also mean 8 objects divided into 2 groups. Okay, in this case, you would have 2 groups that have 4 each. So that's 2 different ways you can view your division problem. And they spend a fair amount of time in 6-1 talking just about this. So let's continue on the next page. Okay, so one interpretation is how many groups. So A divided by B means the number of groups that are formed when A objects are divided into groups with B objects in each group. So here is A is divided into groups that have B objects in each. Okay, so that's one interpretation. In this situation, the divisor equals the number of objects in each group. So remember, the 6 is the divisor. The quotient, which is the answer, so the quotient would be the 3. So this would be your quotient. It tells you how many groups you have. And then lastly, the dividend is the number of items to be divided. So this, I should have changed colors, would be the dividend. Okay, so if I had 20 groups, and I'm going to divide them into 5, so I want to have 5 items in each group, that's going to give me 4 groups. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So the how many groups is what you're answering the question. So your question gets answered by your quotient. Okay, let's go on to the next page. So here, we're going to look at the other interpretation. And that begins here. So that is distinguishing how many groups from how many in each group. Okay, so let me rephrase for a second. So let's start up here. So this says, instead of saying how many groups, this says how many in each group. Notice it's the exact same equation. So we're just using the exact same thing to mean something different. And what they're going to do, they're going to give you a word problem, and they're going to say, oh, which of these applications are we talking about? How many in each group or how many groups? So in this situation, 18 divided by 6 equals 3. A divided by B means the number of objects that are in each group. So your answer is number in each group. Okay, let's go back for a second. On this page, your answer was number of groups. Do you see the difference? This was the number of groups. So I had 3 groups, and that was my answer. In the how many in each group problem, the answer will be the number in each of the groups. We already know that we are going to have 6 groups. But the question is, how many are in each group? Okay, so here I go through the divisor, the quotient, and the dividend once again. So the divisor equals the number of groups. So we'll keep that blue. So that's your divisor. Your quotient equals the number in each group. We'll have that be red. That's your answer. So these are the number in each group. And again, the dividend is the number of items that we're dividing. So it's the biggest number. All right? So, as I said, they're going to start asking us to distinguish between how many groups from how many in each group problems. To help distinguish one type from another, we can reformulate the problem in terms of multiplication. So, for example, we start out with the example of the potting soil. So let's do this on the next page. Okay, distinguish how many groups from how many other groups. Here's my example. You can see all of the example this way. So 5 cups of potting soil filled 3 of the hanging pots I was preparing for planting. I just found 1 more hanging pot that I would like to use. How many cups of potting soil are needed to fill this last hanging pot? Okay, so what are they asking us? We have to figure out how much we want to have in each pot. So this is a how many in each. And the groups in this situation are the pots. So look how I'm going to reformulate it. What I was having was the equation 5 divided by 3 equals x. But I'm going to reformulate it as multiplication. So 3, the number of groups, times how many in each group, has to equal 5. So when you're looking for the amount in each group, that's how you would set it up. So this is a how many in each group problem. Okay, and you can solve this clearly by division, and your answer would be, I would need another 1 2/3 cups, because that's what I used in each of the original problems. So let's use the exact same numbers, or the same procedure, and figure out what I have. So the procedure is changing into multiplication. The mulch costs about $30 per yard, and you have $200 to spend on mulch. How many yards of mulch can you buy? So the yards of mulch is the number of groups. That's what you're looking for. You're looking for number of groups times the amount in each group is already given. So this will be in each group. And here is your total amount. So what was your problem previously? Previously, remember, it was a division. And it was 200 divided by 30 gives me a number that will be how many groups. Okay, so the how many groups problems, you end up getting 6 2/3 of a yard. In terms of the economics of it, you're probably only going to order whole yards, but that doesn't really matter to this case. But you can see in the first problem, the number of groups was already solved. In this second problem, the number of groups is what they're looking for. So you have to kind of think about that to wrap your head around it. Let's go on to the next page. Okay, so here there's a class activity 6B that I want you to look at, and this is an array problem. Array problems are very, very, very popular in math. They help with lots of things. They help have kids understand division, multiplication, area. They are terrific problems. Plus, they're very user-friendly and colorful and engaging. So here we have 15 little ducks lined up in 3 rows. How many ducks are in each row? So you want to know the amount of ducks in each. So here's your division. 3 divided by 15. You're going to get 5. What is 5? 5 is the number of rows. So here are your rows. Here are your columns. Here it is demonstrated in an array. And so the answer kind of spells itself out, because you can just have even young children be able to count how many rows and columns we have. So if I say, okay, we have 3 columns that are being read down this way, how many in each column? You can easily see that there are 3. Okay, the next topic, or one of the topics they discover in this chapter, is they talk about why we can't divide by 0. So I have a TED Talk that I gave you a link to. This is kind of an interesting topic because many times kids want to divide by 0. And even in the higher levels of math, you can never divide by 0. Game over when you divide by 0. So I kind of like the TED Talk because he goes back and talks about the concept of multiplicative inverses and imaginary numbers. Imaginary numbers are kind of beyond our course, but the multiplicative inverse is kind of an interesting way to think about it. So I want you to look at that when you have a second and see if that rings true for you, if that makes sense. So let's go on to the next page. All right. These are rules that you have to know and that kids struggle with. So if you have a negative, so we'll try some of these. So let's do some of these problems. A negative, like a negative 20, divided by a positive, will always give you a negative back. Okay, so that's one concept. Then the next concept is a positive divided by a negative will always give you a positive back. And the last one, a negative, so we'll do 30, divided by a negative, will always give you a positive back. All right, so if those rules are not comfortable for you, you want to work on them. So the only way, if in multiplication, so let's change each of these to multiplication. We'll work backwards. Multiplication, this would be 3 times negative 10 will give you a negative 30. So when you have opposite signs, you always get a negative. Okay, I'm going to reverse the colors. Okay, this problem is division, but for multiplication, it's 4 times a negative 5 will give you a, hold on a second, that's not right. This is supposed to be negative. It will give you, negative times negative will give you a positive. So if you have 2 of the same, it will give you a positive. And then the last one, turn this into multiplication. Negative 4 by 5. Oh, those are opposites. That will have to give me a negative. Thinking of it that way also helps. Same can be true for the red. What if we made them both positive? So they're both positive. In multiplication, you will get a positive. The only time you get a negative is when you have 2 different signs in a multiplication problem. Okay? So let's go on to the next page. Okay, this brings us to 6.2. So this is kind of interesting also, because division and fractions look alike, but they have different meanings, especially when you first start working on this. So if you say that you're going to give me 3/5 of a candy bar, I am thinking that you have some candy bar, and it's divided into fifths, and you're going to give me less than a whole. You're going to give me that much of the candy bar. As opposed to if you had 3 candy bars and you divided it among 3 people, among 5 people. That's a different story. So 3 divided by 5 is the amount of candy each person will receive if 3 candy bars are divided equally among 5 people. So it's a slightly different problem. Here is a fraction. Here is the number sentence. That's a division problem. Here you have the whole for the first one is 5 or fifths. These are wholes. So 3 whole candy bars divided into 5 pieces. That's more candy than what we're talking about when we take 1 bar and I divide that 1 bar into 5 pieces and give you 3 of them. Okay, so think about the difference there. They have different meanings. Okay, so fractions with negative numerators or denominators, they follow the same rules that we just went through. Okay, I did it as fractions. You can do it as divisions. You'll get the same pattern over and over again. A negative divided by a positive is going to be a negative. Okay, you have opposite signs. You'll always get a negative. Opposite signs, you'll get a negative. Same signs, you'll get a positive. If these were both positive, they would also give you a positive. Okay, there are 2 types of divisions. You can do exact division versus division with a remainder. Okay, for division with a remainder, the connection between division and multiplication is different than it is for exact division. So for example, 23 divided by 4 has a whole number, and then it has a remainder of 3. This corresponds with equations that involve multiplication and division. Okay, so look what's happening here, multiplication and addition, sorry. So in order to get this back, what would I say? I would say 5 times 4, here's this 5 times this 4, plus 3 more gives me 23. Okay? So I have 2 operations going on there. The remainder is the addition part of the operation. The whole number is by virtue of multiplication. Okay? Then let's look. So that was division with a remainder. So now let's look and see if you have exact division, which is this situation. What do we have? 23 divided by 4 gives me 5 and 75 hundredths. I'm not having a remainder. I'm doing it exactly. I'm utilizing decimals. In that situation, to get the number back, all you need to do is multiplication. Okay, so when you have a remainder, you need 2 operations to get the original number back. When you have an exact division, you have only 1 operation. Okay, so then they go on to talk about connecting whole numbers with remainder answers to mixed number answers. Okay, so that sounds terribly confusing. But remember when we did 23 divided by 4, and I said it was a whole number and a remainder of 3? All you do is take the 3 and you put it over the 23, and you have the remainder over the divisor. And now you have what's called a mixed number. So a mixed number has a whole number part. This is the whole number part. and then it has a fraction part. It's a mix of wholes and fractions. Using division to convert improper fractions to mixed numbers. Okay, what's an improper fraction? An improper fraction is a fraction that's top-heavy. Okay, it's top-heavy. Many times they will say, do not leave your answer as an improper fraction. In order to change it into a mixed number, you do division. You say 27 divided by 4, and what do you get? The closest number is 6, right? 6 times 4 is 24, and then you have 3 left over. So you have 3. What's your denominator going to be? It's going to be the same denominator I had here. Those are equivalent. Can I get it back to make sure that I've done it correctly? Yes, I can. 6 times 4 plus 3 gives me 27. So you can state this two ways. 27 minus 4 equals, this is one way, 6 remainder 3, or 6 3/4. And guess what? You can turn 6 3/4 into 6.75, which is the exact answer format. Okay, this is also an exact answer. Here is the remainder problem. Okay, all right, so let's go on to the next page. Okay, when we do division, we tend to do algorithms. You can certainly do a whole lot of guess and check, but that gets old pretty quickly. So there are two ways that both the textbook does, and you'll probably use it in your textbooks as well. The first way is the scaffolding method of division. A lot of times you'll do that first with your students, and then there's the second way, which is the standard division algorithm. So there are videos here that I'm going to have you look at, but I'm going to do a problem for you so that you can see the difference between the scaffold method of division and the standard algorithm. Okay, so in the video I have right here, you're going to be able to watch how they do 435 divided by 12. So why don't we do something a little bit shorter so I can fit it here on the page, and I'll do it in the scaffold method. So what if I said, 215 divided by 4. Okay, so 4 goes into 215, let's think, 50 times. So I would put 50 here. And the reason why I'm starting 1 in is because I'm not saying, well, you'll see. So 4 times 50 gives me 215. It's important to line up your 10s and your 1s. That's why I have 50 1 over and not on, I don't have the 5 on top of the 2. Okay, so 50 times 4 gives me the 200. Do your subtraction. Next, 4 goes into 15 3 times. Notice where I'm putting this, right above. So 4 times 3 is 12. I have a remainder of 3. So I would say that my answer is add the 50 and the 3. So 53 remainder 3, or 53 3/4, which can be written as 53.75. Okay, so that's scaffolding. You build upon itself. Okay, that's as opposed to the standard algorithm. So let's do that next. Okay, so during the standard algorithm, I'll use the same numbers. So 4 going to 215. So 4 cannot go into 2, but 4 can go into 21. How many times? 5 times. Put a 5 above the 1 in the 21. 4 times 5 is 20. I'm going to subtract. I get the 1 and bring down the next term. 4 goes into 15, 3 times, put it right next to it. 3 times 4 is 12, subtract and get 3. Either method I get 53, remainder 3. So the difference between scaffolding is you stack your numbers up above that division line, and you do not do that in the standard algorithm. So a couple of things. When this instructor in this video down here does this, she writes DMSB, which is divide. So divide 4 into 215, multiply, 4 times 5 is 20, subtract 200 from 215, bring down. Okay, so I got the 1 and I brought down the 5. And a way that kids sometimes remember it is dad, mom, sister, brother. So they go through that method, and that's very, very helpful, especially for kids just envisioning it. And just writing the DMSB on the board kind of keeps them focused on what their procedure is going to be until they get comfortable with it. So this recording has gone kind of long, so I just want to tell you on this last page, I have some more videos for you. And I have references to the class activities. They're all very, very good, and you can use them also for your notebook, for your interactive notebook. So that's it for this video. That covers 6.1 to 6.3.